Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about probability. Now the question that I've chosen to go through here is 2017 Paper 2 Question 1, and in this part I'm on part A. We're told that Connor is going to ring Kira's house every day for 7 consecutive days, and the probability that Kira answers the phone call is 1/5. You should recognize if it tells you the probability she answers it is 1/5, then that means the probability that she doesn't answer it is 4/5. Because there's only two possibilities. Either she will answer it or she won't answer it. Now the first part of the question asks me to find the probability that Kira will answer the phone on the 2nd day, the 4th day and the 6th day, but not on any of the other days. So in other words, she doesn't answer it on the 1st day, 3rd day, 5th day or 7th day, but she does on the 2nd, 4th and 6th. Now individually I know the probability that each one of these things will happen. The probability that she won't answer it on the 1st day is 4/5. The probability she will answer it on the 2nd day is 1/5, and it's always the same probability. So if she's not going to answer it on the 3rd, it's 4/5, 1/5, 4/5, 1/5, and then 4/5. Now in probability, and means multiply. So in this case, I want this to happen, and this, and this, and this. So I want all 7 of these things to happen. So that means you just get your 7 probabilities and you multiply them all by each other. If I multiply these 7 fractions by each other, my final answer in this case is 256 over 78,125. Part B says, find the probability that she will answer the phone for the 4th time on the 7th day. Now this one is completely different to the last one. The last one was a permutation, because in the last one I knew the order. I knew that she won't answer it, then she will answer it, then she won't, then she will. Whereas this one is completely different. All I know is that on the 7th day she's going to answer it for the 4th time, which means that in the first 6 days she answers it 3 times. I don't know if that's the 1st day, the 2nd day and the 3rd day, or if that's the 1st day, the 3rd day and the 6th day. So I don't know which days she's actually answered the phone on, which means that this is actually a combination. Now in this case, you need to recognize that for the first 6 days, to work out the probability that she'll answer it on 3 of those 6 days, this is a Bernoulli trial. I know this is a Bernoulli trial because there's only 2 possibilities. Now there's 4 different things that are required for a Bernoulli trial, so just make sure you go over those. In this case, either Kira will answer the phone or she won't answer the phone, so I can do a Bernoulli trial. First of all, I'm just going to worry about the first 6 days. I need to work out what is the probability that Kira will answer the phone 3 times out of the first 6 days. To work that out, it's going to be 6 choose 3. So I'm going to ring her 6 times and I'm going to be successful 3 times. So it's 6 choose 3. The probability she answers it is 1/5. And I know that this is going to happen on 3 out of the 6 days. So that means it's 1/5 to the power of 3. I also know that she's not going to answer the phone 3 times as well. So that means it's 4/5 to the power of 3. So this means it's 6 choose 3. She's going to answer it 3 times. She's not going to answer it 3 times. And the probability, the value I get for this, it allows for any of the combinations that are possible. Like the 1st day, 2nd day, 3rd day, or the 1st day, 5th day, 6th day, or whatever it is. So this is the probability she'll answer it 3 times in the first 6 days. And I have to do a Bernoulli trial for that. But now on the 7th day, I know that I definitely want her to answer the phone on the 7th day. So that means on the 7th day, I want this to happen. I want her to answer it, so that means I'm going to multiply by 1/5. This is the probability she answers it 3 times in the first 6 days, and this is the probability she answers it on the 7th day. So if I just multiply all of these by each other, my final answer in this case is 256 over 15625. In part C now, this is the tricky part. I'm told that Connor rings Kira's house once every day for n days. And I'm asked to find the probability that Kira will answer the phone at least once. Now the word at least poses a serious problem here. That means she's either going to answer it once or twice or 3 times or 4 times or 5 times or 6 times or 7 times or however amount of times. And the problem is, I don't know what the value of n is. So n could be 1,000,000. That means I'd have to technically do it 1,000,000 times. But the issue here is that we don't actually know what the value of n is. So it's impossible for us to work out the first one, the second one, the third one, the fourth one, and so on. The only way we can work this out is by looking at what is the only thing that we don't want to happen. So I want her to answer the phone at least once, which means the only thing that I don't want to happen is I don't want her, the only thing that's not feasible in this scenario is that Kira never answers the phone. So the only thing I can do here is 1 minus the probability that she never answers it. Okay? 1 minus the probability that she never answers it. In here, in this scenario, the 1 represents 100% of the possibilities. So it's all of the possibilities minus the possibility that she never answers it. If I exclude the possibility she never answers it, I'm left with all the other scenarios. The scenario that she answers it once, twice, 3 times, 4 times, or whatever it adds up to. So the only possible way of doing this is all the possibilities minus the only possibility that I don't want. To work out the probability she never answers it, we need to do a Bernoulli trial. Okay? So it's 1 minus... Now I know Connor is going to ring her n times, and that she's never going to answer it. So that means the number of times he tries is n, the number of times he's successful is 0. So n choose 0. And the probability she answers the phone is 1/5, so I know it's going to be 1/5 to the power of 0, because that's never going to happen. I know that she's going to ring him n times, and every single time, he's going to ring her n times, and every single time that he rings her, she's not going to pick it up. So if he rings her n times, then no answer is going to happen n times. So it's 4/5 to the power of n. So this is 100% of all the possibilities minus the only one that I don't want to include, which is the chances that she never answers it. And now this one works out nice enough for us. If you put any number choose 0 into your calculator, you're just going to get 1. So n choose 0 is 1. Any number to the power of 0 is just 1. So that means 1/5 to the power of 0 is 1 as well. So all I'm left with is that's a 1, that's a 1. So all I'm left with is 4/5 to the power of n. So my final answer in this case, in terms of n, is 1 minus 4/5 to the power of n. In the final part of this question, we're asked to find the minimum number of times that Connor can ring Kira for which the probability that she'll answer it at least once is greater than 99%. Now what I'm going to do is I'm going to work out what are the chances, how many times does he have to ring her in order for the probability she answers it to be equal to 99%. So I'm going to take it as equal to 99%, and when I get my answer, I'll worry about the minimum value of n. So in this case, I've got one equation, one unknown, which means I can find the value of n. You should realize that your unknown is in the power, which means at some point here, I'm going to have to introduce logs. So I want to isolate the term with the unknown in the power, which means I'm going to subtract 1 from both sides. It'll just be 0.99 minus 1. So this side can stay the same, and 0.99 minus 1 is minus 0.01. At that stage, I could multiply both sides by minus 1, and they both just become pluses. So I get 4/5 power of n, and I get 0.01. Now once I've isolated the term with the unknown in the power, I can just introduce logs. So all I have to do is introduce ln on both sides. So ln 4/5 to the power of n is equal to ln 0.01. Now the reason we're introducing logs is because now I can use the rules of logs. If I've log of something to a power, I can just bring the power in front. So all of a sudden on the next line, my unknown in the power is gone. There's no longer any powers. And I've brought my n down. So in order to isolate n here, I want to divide both sides by ln 4/5. So I could say n is equal to ln 0.01 over ln 4/5. And if you just plug all that into your calculator, you work out that n is equal to 20.63. So that means that if Connor rang Kira's house every day for 20.63 days, there's a 99% chance that Kira will answer it at least once. But obviously it's impossible to ring someone 20.63 times. So in this case, my final answer is that Connor needs to ring her at least 21 times. If Connor rings her 21 times, there's a 99% chance, or even greater, that she's going to answer the phone. Okay, so I hope this video made sense. If there's anything you're unsure of there, or if you want me to clarify something, just let me know in class or send me an email and I'll try and explain it differently.